All right, today we are in 2.2.1, which is a lesson about power functions. All right, so I'll be talking to you more about those in just a moment. I want to review a little bit with you, though. Number one thing I want you to review is, do you remember how to complete the square? That's what I'm going to call the vertex CTX. CTS, sorry. CTS. Why vertex CTS? Because you're going to be asked to find the vertex, and you'll be like, how am I supposed to find the vertex off of this? It's not even in general form. And so you will hopefully remember how to do the vertex CTS, complete the square. Looks like kind of a car brand. All right, see if you can complete the square on that one. I'm going to pause for a second while you give that a try. When you're done, if you turn it my way, I'll tell you whether or not you did it right. Billboard it to me on your iPad. Here we go. You should have, first of all, move that 1 over, and you'd have y equals x squared plus 8x plus 1 way over there. Half of the 8 is 4. 4 squared is 16. So you do plus 16 and minus 16. Then this part right here becomes your perfect square. Y equals x plus 4 quantity squared. Those guys go together, minus 15. Why am I doing this? Let's say you were in a word problem where they wanted to know the highest that the ball ever went, or the lowest that the submarine ever went. Those highest and lowest spots, they are vertexes, right? Think about it. The highest spot on a parabola or the lowest spot in a parabola, they'd be vertexes. So this finds the vertex for us. Negative 4 comma negative 15. Okay, raise your hand if you understood that one. All right, good. Now I'm going to do another one, and this is the formula for, now we're not going to actually do this one because it's just too nasty to have to factor out a negative 4.9. But this is the formula for the gravitational constant. This is a velocity, and that is a starting height. Okay, this is a fancy-looking quadratic that tells us if I had an object and I tossed it in the air, like for instance, I'm going to toss this whiteboard bottle, okay, and I'm going to start at 1 meter off the ground. Okay, this is the plus 1 there. Why is that? That's the y-intercept. Doesn't it make sense that if I had a graph of it, that the y-intercept would be where the thing starts? And then you toss it up in the air and it comes back down again. This is going to be time, graph versus height. Okay, and of course that number in front is the gravitational part. It's actually half, and then it's multiplied by the, I can't remember exactly what it is, in meters per second that gravity pulls. But anyway, 9.8 was it? Okay. Okay, thank you. Awesome. Some people that really know their gravitational constants. All right. So anyway, this is the velocity, how fast you're throwing the thing, and this thing is the y-intercept, the starting height. So if this bottle is up about a meter, and I toss it at 5 meters per second, and it goes back down, that path you saw it travel was a parabola. Okay? If I had you do complete the square on this thing, you'd be able to find the vertex. Because that's what complete square does. Okay, so if I did that, you'd be able to find the vertex, which means you'd be able to find the highest that the bottle ever went. Okay? Now, that brings me to the topic of gravity, because of course, if I had done that same exact thing on the moon, do you get that the bottle would have been went up higher, for example? And gravity is kind of a fascinating topic. I'm going to pause for a second to talk about it. All right, we're done talking about gravity now. If I had you do this one, I would change this to a 5, because then this is going to factor really nicely and easily. Would you try to complete the square on this thing now? I'm going to pause for a second while you try completing the square. This is a typical R2.5 or R3 easy kind of question. Okay, if you get stuck up, I'm going to show you a little idea of how to start. Take out the negative 5. And that part right there was probably the hardest. You inside part here, all you have to do is make it so that this times this would equal that. All right, now we do half and square. Half of -1 is a half. And then it's negative a half. But then I'm going to square it. The half and squared makes 1/2 squared. Yes, you could put 1/2 and then a squared on it like this. Or you could do 1/4, because that's what 1/2 times 1/2 is. I'm going to put plus that, and I'm going to put minus that over here. And again, I'm going to go to the 1/4 version for right here. I hope you get that this and this would be equal to each other. Then you'd have y equals -5 times x minus 1/2 squared. And then this part right here makes 3/4. So what happened there? I found the vertex, which would be 1/2 3/4. Oh, you caught me. Thank you. As soon as you said you have to multiply, I remembered. Yes, you're right. I forgot. This guy right here that we factored out to the front has to now get multiplied here times by -5. Thank you for catching that. Okay, so then I got -5/4 plus 1, and that means -1/4, right? So final answer, y equals -5 times x minus a half, quantity squared, minus 1/4. And then the vertex is 1/2, comma, -1/4. And, say that again? Is this a plus 5/4? Is that a plus 5/4? Oh, yes, because of the multiplying by the negative. Thank you. And you know what? I was actually looking at my graph going 1/2, comma, -1/4 is over here. And I was about to try to explain why the vertex would be over there. And it's not. So thank you. Actually, 1/2 -1/4 would be down here. But anyway, it was going to be off. So thanks for catching that. Man, too many mistakes. I had a whole bunch of cookies at lunch. I'm going to blame that. It does affect your brain. Okay, 1 1/4 plus 2 is 2 1/4. Do you realize that your brain eats 30% of your calories that you take in? Your brain is burning 30% of the total usage that you eat. So when I eat a cookie, my brain's eating 1/3 of a cookie. All right. And brains don't like to eat cookies. Wise quotes from Mr. Serger. All right, so 1/2, comma, 2 1/4. All right, now, can that actually seem like it could work? Yep. That's over a half of a second. It was at its maximum, which really makes sense. I was tossing that bottle in the air. Remember, we rounded this. It was 4.9, but we rounded to 5. So this isn't perfect. And it at 1/2, comma, 2 1/4, that meant that I was up a couple meters off the ground at its very peak. All right, good enough. That is called completing the square. It's one of the things you're supposed to be good at by now. Another thing that we learned was about regressions. So hopefully, if we look at the increase in carp in Minnesota, we've had this invasive species come up the Mississippi River, such that you can drive a boat up the river and have these carp jumping up behind the boat. It's pretty hilarious. How many of you guys have actually seen a video of that? It's only like 6 people. I may have to show you that later. So this is going to be let's say go by months. In month 2 versus month 3, 4, 5, 6, they tracked these carp, and it went from 5 to 10 sightings to 17, very good, to 26, and 37. You got it. All right. I'd like you to put that in your calculator and see if you can find me the quadratic regression, and then be able to predict for me what month 10 would hold. In reality, is it in your calculator already? Same table? It actually might change no, it probably won't change your data to add a couple more points to it. But Anyway, just predict month 10. And I shouldn't have used that same exact factor, but it really doesn't matter. The process of typing it in and doing this is going to be the important part. Okay, I'm going to pause for just a second while I put in that data. I've got my data in here now, and I'm going to go to Stat, calculate the quadratic regressions number 5, and my new operating system, it wants me to put it in this way, and on my store regression equations where I put my y1. If you have the old operating system, you should have typed in L1, comma L2, comma y1. All right, please don't talk right now. All right, so I'm going to go to vars and y vars, enter, enter. Okay, then I'm going down to calculate it, and hopefully yours looks like that. And I'm going to go to my y equals, and it shows me the equation that I needed right there. And then I hope that you were able to go to your table to predict your 10th, and there it is. 10 would be 101. Raise your hand if you know what I'm talking about. Okay, and a lot of people didn't raise their hand. Does that mean really that you don't know? Tell me if you don't know. If you don't understand this, let me help you. Okay, I'm going to pause for a second. All right, so you got a chance to see that. Now, we're going to get into the new stuff for today, which is called power functions. And they are like this. That is a power function. You might want to write this down. Okay? This is the power in the power function. And this is the COV, I'm just shortcutting, it's constant of variation. The constant of variation. So a typical problem then has something like this. Y equals 6 x to the second c. And it'll just mess with you a little bit on that c. And you got to say, okay, well, is this a power function or not? Well, if it has a variable that has been put to a power, then it is a power function. Okay? And then you just got to figure out, could it have been rearranged like this? 6cx to the second. Would that have been okay? Okay, pay attention here. It's not on your iPad. It's up here. Thank you. Be with me. So this part right here then has become the constant, even though it's got a c in it. Is that okay? Yeah. Variables can be constants if they are predefined as constants. So we use c and g and k as variables, but they're not variables. They have been assigned numbers, and therefore they are going to be constants. So this one is the one that really messes with people then. If I go 6c to the third x, everybody says, yeah, it's a power function, and the power is 3. Wrong. Because that's a constant. That's constant means it's been assigned a number. That's a number cube. Like it could be 8, and then you cube it. It's some really big number now. Maybe I should have picked 1 so I can cube it. 1 cubed is 1, and 1 times 6 is 6. So the constant is all of this. That's just the constant. So it was a power function, but what was the power? 1. Because this x has a 1 on it, so the power is really power of 1. And this was really a constant. Okay, it can get a little bit more intense too. Let's say I had 6 over x squared. Well, first thing you have to do is to rewrite this puppy all on one line. So you'd want to write y equals 6x to the negative second. Why did I do that? Because now it becomes more clear what the power in the power function really was. The power was not a 2. Power is what? Negative 2. Okay. So this was a power function, but its power was not 2. It has to be written in standard form for you to be able to judge its power. Now that I've rewritten it this way, its power is negative 2. And what was its constant? 6. All right. So this is called a constant of variation, COV. This is the power in the power function. And sometimes we mess with you like this. We'll say 6c squared, and then just say, okay, is it a power function? No, because c is a constant. And k is also a constant. And this doesn't have a variable to a power. This is just as if I had written y equals 8. It's just a constant. So is this a power function? No. That's not a power function. So this whole thing is not a power function. Had this been an x, yep, then it would have been a power function, and the constant of variation would have been what? 6. Okay. So how about this? Y equals 1 over 2x to the negative second. I'd like you to try to figure out for me if this is a power function. And if so, what is its power and what is its constant of variation? Right away you should rewrite it, because the way it is, with that fraction in there, the way it is, you could not give me a good answer. See if you're right. Yes, that's right. No. Yep. Put COV next to your constant of variation and put a power where P equals whatever, so I know your power is. That's fine. Yes. No, wait, the constant of variation is wrong, but your power is good. Yes, that's right. Yes. Your power is wrong, but you generally have the right idea. Yes, that's right. Nope, constant variation is messed up still. Here's the part you need to understand. This is a 1/2, and it's fine. So do you get that the 1/2 is fine, but the x squared really should be moved? X to the negative second power. We used to talk about these as those powers are not happy where they are, so we should move them up here. I don't know if you remember doing that in higher algebra. That's the same exact thing as this, and it's a lot easier to read. Can you tell? Is it a power function? Yep. And what's its power? 2. And what's its constant of variation? 1/2. That's the constant of variation. Okay, one more. Let's say we had y equals, let me think, I want to make one where okay, it's got a fraction in it, and there we go. Okay. Is this a power function? If so, what is its constant of variation? And what is its power? Right. Right, right. If you're busy trying to figure out its constant and all that stuff, then you're doing it wrong. Good, good, good. Nope. You overthought it. Yep, yep. And I know that happens. Thanks for just saying it out loud. Good. I know that a lot of times you'll see what I said was the right answer, and you're like, what the heck? Why is it no? So you know it's no, but you don't know why. Okay, no, it's not a power function, because do you get that's supposed to be the x and that's supposed to be the number? You can't have an x in the power, otherwise it's not a power function. Okay? These two would have been reversed, and this would have been x to the second, then yeah, then it would have been a power function. And just for kicks then, if that is a power function, what's its constant? Its power was 2, that's the easy part. That whole thing is the constant. Remember, k is a constant. K is a number. Just like c is also just considered a number. Now that has to be predefined ahead of time, and I did tell you that c's and k's are going to be constants. All right, let's look at your worksheet for today. I think you'll see it's not too bad. So find it. It's 2.2.1. 2.2.1. I'm going to pause for a second while I bring it up. Okay, I've got the worksheet up on the screen here. 2.2, number 1. In fact, there's a few other things I forgot to mention that are constants. Focus, please. Focus. Thank you. This C and K, I talked about those as constants, but we also use G. And of course, I hope you know this, pi is a constant. It's a number. We don't use pi as a variable ever, right? We use pi as 3.14. All of these things are numbers, and therefore constants. So whenever you see them, don't get distracted and think they're variables, because they're not. Only x will be the variable, or anything, any other letter that's not one of these. So actually, if we threw a y in, that would be a variable. But if we use a C, a G, a K, or a pi, those are all just constants, so you just got to think, oh, that's like a number. Yes? No? Variables are empty spots that you can put anything. You can put other variables in variables. You can put numbers. You can put imaginary numbers in there, all kinds of things. But it depends. You don't have to be a number. Variable can be just a letter. Okay? So, you do have to understand that they are different. If I say this is a constant, then I have said it is a number. I just haven't told you what the number was. As opposed to a variable, which has not been assigned a number and gets treated differently. Okay, so look at this one. And do you get that that is a power function? Okay, so what is, your job is, for those that are power functions, state the power and constant of variation. I'm totally fine with you saying yes, first of all, that it is a power function. And then to state the power, I go P equals, and what is it? Much less complicated than that. The power is what? 5, okay. And then the COV would be constant of variation, would be negative 1/2. Okay? All right. Now look at this next one. Now, on the rule, the deal with polynomials was that they had to have nice exponents. This doesn't have that rule. We never said that. Okay? So, I'm going to pause for a second. Okay. So, this one. This is a power function. And its power is, so first of all, yes. And its power is 5/3. And its constant of COV, constant of variation, is just that number in front of it, which is a 9. Okay, this next one. Does it follow that same pattern? Does it follow the pattern for a power function? No, it's a no. Why? Because x is supposed to be the base. That can't be the power. If you have a x in the exponent, then you're called exponential. We will teach you about exponential functions later. That technically is an exponential function because it has an x in the exponent. All right, this guy doesn't have an x at all. So is he a power function? No. If anything, it has a power of x to the 0, and that's a weird one. So that one's not considered a power function. All right, clear this off. Having issues pausing. Okay, take a look at 5. Do you remember me saying there would be times like this? So do you remember what the deal was? Is this a power function or not? The question really is M a constant? I think those of you that are catching this know that C is a constant. Therefore, that's just like a number squared, like 5 squared, so that's like a 25. So we don't count that. That doesn't count. But is the M a constant or not? All right, so if we look in the constants list, which I don't want to try to scroll to because it's hard technically here, I'm not going to see M in the list. M is not considered a constant, therefore it must be a variable. And therefore it's just like it was y equals xc squared, and therefore that is a power function and it has a power of 1. This part right here then is the 3 letters. COV, constant of variation. All right, so the bottom line answer is yes, this is a power function. Its power is 1, because that's the little 1 that's on the variable. That's the constant. So I'm going to call it a constant of variation. That's this part right there. Okay. It has to have a variable that has a power on it. Can't be, well, because technically it would be x to the 0 power if it wasn't there, and therefore I have to say it has to have a power. The power can't be 0. How about that? Y equals x is a power function because it's got a power of 1 and a constant variation of 1. That's a good question. Yes. Could I do 10? I probably could. I'll pause for a second, see if I can get that. Actually, maybe I can just get there quickly. Okay. Down to 10. There it is. Okay. Don't let them fool you with the f of a. That just means like y equals. Just like f of x, right? That doesn't really matter. Is m a variable? Well, the only choice is it's a variable or it's a constant. Which one is it? Is it a constant? It's not on our list of constants, so it's not a constant. So yeah, it's a variable. How about a? Okay, so this has got two variables in it. And if so, it is not a power function. Otherwise, you'd have to tell which of the powers is power. You know, is it the power that's on this one, or is it the power that's on that one, or do you multiply them? So I could be proven wrong on this later. I'm going to double check my notes, but I'm 90% sure this is not a power function. Yes? Ooh, good point. But still, I've got another variable in there. So I hear you that this is the variable that they are looking for. Since it has another variable in it, though, I don't think you're allowed to have two variables in one of these. It would sort of be like what we're used to as variables, x and y, and this is squared and this is cubed. Is that a power function? I don't think so, because it's got two variables. But I do see your point that that is telling me that this is the variable that they're kind of focusing on, and that's important. Glad you noticed that. But still don't think it's a power function. But I'll check for you, and if it is, I'll make sure to tell you that tomorrow. All right. Let's move further and see if there's more interesting stuff here. All right. There is those are monomial functions, state the degree and the leading coefficient. All right. So monomial functions as opposed to a regular one. All right. Technical issues. Sorry. Keep on tapping. Drag this down. There. Okay. There. Good enough. Okay. Determine whether the function is a monomial. That really means a polynomial. What was the rule on polynomials again? They couldn't have weird what? Exponents. So now we have to be careful to say it might even be a power function, but it might not be a monomial function. All right? And it's in a polynomial. All right, so this one, well, first of all, this doesn't even have an x. So is it a power function at all? No. Is it a monomial function? Is it a polynomial? What was the rule for polynomials? They can't have weird powers. This has a weird power. It's like an x to the 0 is tacked onto this. Because x to the 0 is equal to 1, right? That has a weird power. And I am not completely confident in this. I apologize. I was not ready to talk about how weird the powers could be. So I'll have to find that out for you for Monday. But my gut on this one says that that is a weird power and therefore not a monomial. I mean, it's one term, which makes me think maybe it is a monomial, but I don't think it's a monomial function. And I'm not nearly as positive on that one. I will find out for you for tomorrow. This one I can guarantee you, because it's got a weird power. -5 is definitely considered weird. I can't remember if 0 is considered a weird power or not. So this one is just like it was like this. It would have been a power function, but it's not a monomial because it's not a polynomial because it's got a weird power. Okay, this one. Finally, one that's a power function and it's also a monomial function. Yes? It is a monomial. All right, okay. I wasn't sure on 0. I thank you for that update. I am going to change my opinion because I was really wavering anyway, and she says that the key says that it works. Why is this a monomial? Because it's got an x to the 0 on it, and that's not too weird of a power. I'm going based on this whole weird power thing because that's what I told you before. Look at the power on it. And if the power on it is a fraction, or if the power on it is a negative, then those were weird powers. And that's how we were judging whether something was a monomial or a polynomial. Apparently, this is okay to be a monomial. It's not a critical topic. We are not going to spend much time on this, but I'll teach it to you right anyway. Okay, so this one's a yes. It is a monomial because 0 is apparently okay for a power in polynomial world. All right, back to this one. Monomial or not? Isn't that power kind of weird? Yeah, so if it's not, if it's got a weird power, it's not a polynomial. No. Okay, I think I've done enough of your practice problems here. So that's all I have for the video for today.